So we were introducing a lot of terminology having to do with different types of graphs. We had talked about just multigraph, right? Pseudograph. So a pretty common type of graph that we'll encounter is what's called a simple graph. The simple graph is exactly like it sounds. It doesn't have anything complicated about it, right? Simple, right? It shouldn't be complicated. So it doesn't have any loops, doesn't have any multiple edges. So a simple graph is a graph without multiple edges or loops. So no multiple edges, no loops. Yeah. Oh, these are pretty common, I think. Just to an example. This is an example here of a simple graph. We got A, B, C, D, E, F. And we have edges. We don't have any loops, and we don't have any repeated edges. So this is a repeated graph. Sorry, a simple graph. This is a simple graph. Okay. All right, so now we're ready to look at what a directed graph is. So this is a new thing. Definition. So before we get into directed graph, we want to talk about what is a directed edge. Directed edge. So an association between two vertices in which order matters is called a directed edge. A directed edge. So the key here is that order matters. So here's a little bit of representation with notation. So let's say I have an edge. I have two vertices, A and B. And I have an edge, and I put an arrow on that edge to indicate that order matters. So that represents maybe some kind of flow from one vertex to the next. So some flow from A to B, and it only goes in one direction. So notation here is we write for this edge, rather than writing the curly braces A, B, we're going to put parentheses A, comma, B. So anytime you see parentheses, that means order matters, right? When you're talking about ordered pairs when you're doing like basic algebra, X, Y values, the order matters. The X is important and the Y is important. So here, the order matters. So we write A, comma, B to denote this directed edge here. The directed edge. Where A is the starting place, the beginning, and B is the end. Okay, that's just some notation. Okay, so what we want to define next is what is a directed graph. Definition. A directed graph is what we're defining. Consists of a non-empty set of vertices. Non-empty set of vertices. So you have vertices like you did before. And a set of directed edges, E and a set of directed edges. So this time your edge set is going to consist of ordered pairs rather than two element sets or even singleton sets. Okay, so let's look at an example here, just to do an example. So let's say I got A, B, C, D. These are my vertices, and I have an arrow going from A to B. From B to C, we have an edge with an arrow. From C to D, we have an edge with an arrow. Oh, that doesn't look like a nice arrow. Let's see if we can get a better arrow. There we go. And let's see, from A to D, I have an arrow. And from C to A, I have an arrow. So I don't know what this represents. So a lot of times in network flow, graphs like this are useful. For example, you're talking about electrical flow, or maybe water flow, or even traffic flow. These type of graphs are really useful, these directed graphs. So this is a directed graph. I'll just write that. This is a directed graph. And if you wanted to write out the vertices, I mean, they're going to be the same as before. You have what? A, B, C, and D. 4 vertices. But the edges are going to be a little bit different. So order here matters. Let's see. So I'm going to have to go from D to A. So I'm going to put ordered pairs. I'm going to put parentheses, D comma A. I can't do A comma D. Before, it didn't matter if we did DA or AD, but now we have to do DA. We have to start with D and then write A, because that shows that D comes first and then A. We have to do what? A to B. So that's going to be another ordered pair. A comma B in parentheses. What else can we do? We can do B comma C, right? Capture this edge here on the far right. What else do we want to capture? We want to do C comma A. Don't forget C comma A, this edge. The diagonal. And we have one more edge. We got C comma D. C comma D. And we'll just close that set off. That consists of all the edges. Yeah. So if you wanted to write things out nicely in their directed edge set and the vertex set, you can do that. Okay, so let's go to directed graph when you got the arrows. Few more terms we want to add. What is a simple directed graph? Definition. A simple directed graph. That's what we're defining. Is a directed graph with no multiple edges and no loops. No multiple directed edges, I should say, is a directed graph with no multiple directed edges and no loops. Okay, here's an example. So let's say I have just 3 vertices, A, B, and C. Let's put an edge from A to B, an edge going from B to C. Let's say we have an edge going from A to C, and an edge going from C to A. So these are directed edges. So it turns out that this is a simple directed graph. There are no multiple directed edges and no loops. So this is a simple directed graph. So you might think that there's a multiple edge here from A and C, but it's not, right? One of these is AC and the other one is CA, so these are not actually the same edge. So that is not a repeated edge like you might think. Those are different. Okay, so if you actually wanted to write out, not asked to do this, but let's just say you wanted to write out the vertex set, you could do that, right? The vertex set, let's make it red, like we've been doing. Consists of what? A, B, and C. Doesn't matter what order you put the vertices. Order for vertices does not matter. But the edges, that is a different story. The edges are directed. So one of our edges goes from what? A to C. So A comma C, that's one edge. Then you have another edge that goes from what? C to A in the opposite direction. That is not the same edge. CA is not the same as AC. The arrows are going in opposite directions. So actually we do not have a repeated edge. So no, this is not a multiple edge situation, like you might think. All right, then we got A to B. That's another edge. And then we got B to C. That's the last edge. All right, and we'll close that set off. So that's all the directed edges. So none of those are repeated, right? AC is different than CA. So, no, I forgot to write this here, BC. All right. That's a simple directed. So simple directed graph means what? No multiple directed edges and no loops. How about a directed multigraph? That's what we're going to define next. So there's some books that don't define it this way. Actually, a lot of books don't define it this way, but we're going to stick with our book. A directed multigraph so we're defining is a directed graph with multiple, that means repeated, multiple directed edges, and it may have loops. It may have loops. Now, a lot of books don't allow the multigraph here to have loops, the directed multigraph to have loops, but our book does. It's kind of unusual. So we're going to follow our book. The terminology isn't 100% standardized, so we're going to just follow the book. So it may have loops, doesn't have to. Okay, let's do an example. All right, so here we got 3 points. A, B, and C. We're going to have an edge from A to B, an edge from A to B, an edge from B to C, and down here we're going to have a little loop. Directed loop. All right, so this is a directed multigraph, right? You got the arrows and you got the repeated edge right here. AB is a repeated edge. So this is a directed multigraph. So So if you wanted to write everything out nice and pretty, you could put the vertices down, list all the vertices in a set. You got what? A, B, C. 3 vertices, and then the edge set. This is just not an ordinary edge set, right? It's a directed edge set. So first of all, you have what? AB, that's one edge. Then you have AB listed again. We're not going to write that down a second time, but we're going to list the multiplicity later. And we're going to have what? BC. Oops, wrong color. BC, that's another edge. And then you have C goes to itself, right? It just loops around. So we'll just put parentheses around C like that. You could write CC, but no point in doing that. All right, so now, because we have that repeated edge, right, this AB right here is repeated, we have to write multiplicities. Multiplicities for each of these. Since we're doing with a multigraph, you have to have multiplicity. So you got multiplicity. Well, I need to put this down further. Let's scroll. Okay. All right. Let's see the multiplicity of AB. Okay. I'm just going to erase this. Right. Come on. Multiplicity of AB, we'll put it like this, is 2, right? That one showed up twice. Multiplicity of BC, that one showed up only one time, and the multiplicity of just singleton, well, not singleton, degenerate interval C is 1 because that loop only shows up once. There's not 2 loops going around C. Okay, so that's the way you could write everything out in detail if you wanted to. So that encapsulates that guy. And then you have one more thing we can define, which is called a mixed graph. Final definition. A mixed graph has both directed and non-directed edges. Has directed and non-directed edges. All right, let me draw an example of that. What do I want to draw here? Okay. Let's say I got here A, here B, here C, and here D. Let's say we put an arrow going from A to B, then an arrow going from B to A, an arrow going from A to C, an arrow going from C to D, and then let's say we got this side here from B to D that doesn't have an arrow. That means you can go either direction, basically, right? You can go either direction. This is a mixed graph. This is, well, didn't write too well, did it? This is a mixed graph. And that's because we have some combination of undirected edges with directed edges. Now, if you wanted to write everything out nice and fancy, you can put the vertices down and a vertex at right A, B, C, D. No particular order, doesn't matter what order you put in. Then the edges are mixed. You got directed and undirected. So first of all, I'm going to do AB over here. All right, then I got what? BA over here. That's a different ordered pair altogether. Order matters. What else? Do we got AC? AC. What else? Do we got CD? CD. Now I'm out of space. So what I'm going to do, I'm going to put a big old, what do you call that? Curly brace, and then underneath I'm going to write my last edge. Now what do you do with this BD is the question. It doesn't have any direction, right? You can either go forward or backwards. We're just going to use a curly brace, right? Curly braces indicate you can go either direction. BD. So it doesn't matter if you do DB or BD, it doesn't matter. So you got 1, 2, 3, 4, 4 directed edges and 1 non-directed edge. 1 non-directed edge. All right, there, that's, okay, I think I'll stop there with that terminology. So probably in the next video, what we'll do, we'll actually look at some examples where we classify the graphs. So for now, we're done with all this terminology.